Alright, so we're going to investigate this function here, which is related to the normal distribution. Not super relevant, it's more of a fun fact. So let's take a look at this function right here, and we're going to look at how we can answer a bunch of these different questions about it. First, what is its domain? So its domain are the x values it can take. Now, to do this one, normally the exponential is all real x, because the exponential can have any x value can give any y value. But you can actually check this by looking at what happens as x approaches infinity. And as x approaches infinity, if we type in a massive number into our calculator, y is going to approach 0. And similarly, as x approaches negative infinity, y is again going to approach 0. Now, the reason this is going to happen is something we're going to find out a little bit later. But also, and we're looking at the powers here. Anything to the power of something, e to the power of something is what? And it's about investigating that and what it means. So the domain is all real x. And the reason is, as x approaches infinity, y approaches 0. And as x approaches negative infinity, y approaches 0. And there's no vertical asymptotes. And there won't be because of the type of the curve that the exponential is. Determine whether it's even or odd. Remember, if it's even, then f of negative x is equal to f of x. If it's odd, f of negative x is equal to negative fx, which means I can factorize a negative out of the function. So let's take a look at this one. Let's put in f of negative x. I'm going to put negative in there. Negative x squared. And lo and behold, look what's going to happen. What is negative x squared? It's just x squared. And that's going to give us the same function that we had before, which means it's even. And this is really important because if it's even, it's going to be symmetrical. That's a really big part of even functions. That's really important. If it's even, it's going to be symmetrical. And this is actually going to be quite useful later. Find the intercepts. So we can find the x-intercept when y is equal to 0. Now, what you will notice before is that we can't actually do this. If we attempt to solve this by taking the natural log of both sides, this does not exist. We can't have this. So there is no x-intercept. We can't have it. And it's similar to how we have no y-intercept when we look at logs. Because of how the exponential and the log are inverses of each other, the asymptote ends up being is also going to end up being like that as well. But we can find the y-intercept when we let x be equal to 0. We have, which means it's y is e to the negative 1 over 2, 0 squared. E to the power of 0 is 1. So we have a y-intercept at 1. We already investigated the asymptotes before. We know there's no vertical. And that is because the domain is all real y. All real x. The domain is all real x. Phenomenal. I'm not re-recording this. The domain is all real x. Every x value exists, so there's no x values that can't be taken. There's no vertical asymptotes. And the range, this is where we get into a little bit further. The horizontal ones, we already explored. We looked at what happens as x approaches infinity, y approaches 0. And as x approaches negative infinity, y approaches 0. So we have a horizontal asymptote at y is equal to 0 along the x-axis. A horizontal line at y is equal to 0. And now we're going to sketch. We've got my graph here. We know we have a y-intercept there. We know my graph is going to be symmetrical. We know we have, I'll even change the color up a little bit here. We know we've got an asymptote along the x-axis here at y is equal to 0. If we ever, let me just change the color back. We know it's going to be symmetrical because it's an even function. Even so, if we're not sure what to do in terms of sketching, do a quick table of values and see what the sign of y is and what it is approaching. And what you will see, that's 1, lol. What you'll notice if you fill out that table is it ends up looking like this. Just like that. They're all going to be positive. They're all going to be smaller. And they're all going to approach that asymptote. They're going to approach y is equal to 0. So that is investigating the exponential curve, negative half x